Testing. Can you hear me, Kenny? Can you hear me, Kenny? All right. Is it okay to be over at the side like that, or you want me to put it under? You're an under guy.
Yeah.
All right, let's see if that's any better. Yeah, it's cool stuff. I gave this talk in Phoenix a couple of weeks ago, and there's a kid in front, and it kept he was 12. You know how exciting it is to have somebody young in the audience. It's awesome. And you're like, yeah, the next generation. And it kept calling him a girl. And I'm like, you know, these things aren't perfect, you know? It's just a bummer. It just happens. That's what it should do, just to make everybody happy. That's exactly right. The further you are away, the darker it is, whether or not you're smiling, it all plays a role, no doubt. And if I had a much better camera, I kind of wish I did, right? Because if I had a better camera, it would, I could probably get all of you. But it's just, I don't have a better camera. I just have this little dot camera. You know, but it's pretty cool. I could have had this at the front door, and that's pretty neat, you know? I mean, honestly, it is. And watch this. Here's even cooler. So, here, I'll just show you how cool it all really is. Now look, I'll get in it, and it won't call me a male. It'll call me Jerry Nixon. Did you see that? Yeah, it's awesome. And it made me between 43 and 50, which is a ridiculous range. All right, that's good. It's cool. It's really cool. Here, I'll show you a couple others. Oh, by the way, if you haven't seen we still have a minute, right? Yeah. So if you see like the bottom here, this is telling you see how it's guessing whether or not they're smiling or neutral face or whatever they are? And so give me a good smile. Smile for me. Yeah. Right? And it'll find... Right? Good. You're happy. Good. Congratulations. That's great. Everybody's more... And this right here is telling you that the audience generally is more happy than not happy, right? That's cool. And how many people it saw over time... 1 female, 13 males. How many unique people it's seen over time. It isn't perfect, but it's so close. And what the general age range is of the audience, you could just keep going from there. It's really groovy stuff.
So my age changed quite a bit from 43 to 52 or something like that?
The closer you go to the camera, the less it will change, but not necessarily the happier you'll be with the result. Right? All right, this is more like guessing your weight at a circus than it is, like identification at the airport. But it's cool stuff all the way around. I'll show you another cool demo that's built into this that's a lot of fun. Let's see where I can. This one is a great one. Emotional match. So this will. No wait. This is the wrong one. This one is actually terrific. Where it finds a baby that matches. That's. Let's do it again. Try and make a face this time. Try. There you go. Try and make some sort of face. Oh, it only recognizes one. Well, we'll see what here we go. There you go. The perfect baby. That's great. Yeah. Not the one I meant to show, but it's cute too, isn't it? Yeah, it really is. The other one that's fun is, I actually thought that was it. Oh, here it is. Is a motion photo booth. So it's when you make the face. So it's trying to find happy, it's trying to find neutral, it's trying to find sad. Yeah, contemptuous. Yeah, you're doing great. Somebody needs to look surprised. That's a pretty easy one, like like a bright-eyed surprise. And it slowly fills it in. It's great because it's a great thing to play with your friends to see who's the first person to hit it. Thanks for playing along. That was good. All right, there's nothing more awkward than having a camera pointed at you there's a crowd, so we'll just move on from that, but it's still a lot of fun. All right, let's see if I can get started. Say it again. That demo, the APIs that cause that demo are public, but the demo itself isn't. It's called the Intelligent Kiosk. Lots of the code is actually up on GitHub that you can take, but there are parts of it that aren't, for whatever reason. I don't know why we live in a world where we give it all away, right? And so, yeah. Let's see. All right, we're right on. In fact, I'm a minute over. Hi, everybody. My name's Jerry Nixon. I work for Microsoft. There, now you know. I let it out of the bag. I am a developer, and I am a developer evangelist, which, if you know what a developer evangelist is, then you are jealous of my job. So it's great. Just imagine all the work you do. I do that. and I don't have any deliverables at all. So it's really terrific. So just imagine the fun of that. Great. I live in Colorado, which is terrific, by the way. It's nice here, but if you think it's the best, you haven't been to Colorado. Okay. If you haven't done our survey, most of you likely already have by now. If you haven't done our survey, though, this is where you earn the This is where you win the Service Pro, AKMS SVCC. We'll move on. All right. There's a whole bunch of us here, more than attendees almost. It's crazy. You're being invaded by Microsoft. But all right. So that was the intelligent kiosk. It has a lot of cool features. One thing I didn't show you was another thing it can do is everything you saw, but with a recorded video instead, and all of the things that it is able to pull out and identify, make markers in that video so you can jump to it. And so you could take a video and say, show me all the points in this video where Jerry Nixon shows up. And there I am, right? And I mean, it's cool stuff. Show me where every point in the video where there's more than 3 people, where there are less than 3 people. And so imagine how handy that would be, not just for video editing, but also for using a security cameras and on it goes. So this stuff can't be done locally. Part of it actually can be done locally, but the really intense stuff can't. Like I trained it who I was, showed it my face, which by the way, I'll tell you what's cool about that too, is when I trained it on who I was, I trained it on this many photos, right? And so they're just pictures off the internet, right, of me. And then I did a buddy of mine, Adam, who works with me as a colleague. I only did it with 2, same effect, right? It's very effective. It's cool how you can train it so simply, and then all of a sudden it starts recognizing you in a group like that. And that was pretty reliable. It wasn't a big deal to kind of get started that way. There's a lot of other things. Many of them are fun. This kiosk was originally written for the Microsoft Store, so it could be a fun thing for people walk in the store and tell you how old you are. And I'm sure it was insulting to a lot of people there too. Okay. Let's talk about artificial intelligence, what it is, kind of how we got here. Because once you have your head wrapped around it, this stuff is far less terrifying than it is otherwise, right? Because we will all be bowing to our robot overlords eventually. But until then, we can have talks like this where it's not that big of a deal. To where we are, it's actually a pretty cool story. Because it's a short session, I'm going to talk quickly and kind of skim over the story, but I'll still give you the gist of it because I think it's worth it. Let's start with back in the day. So look at it, 1788. This is really close to 1776, right? When everything was born around here. And so this was a long time ago. Computers didn't exist at the time, and yet the father of the computer was alive, and yet the first programmer was alive. Is that crazy or what? It's absolutely true. All right, Lord Byron, he wrote Don Juan. He married his wife, and they had a baby, and her name was, anybody know? Ada Lovelace. Anybody know the first programming language? Ada, weird, foreshadowing. I wonder what I'm going to say next. Okay, so then along comes Charles Babbage. And Charles Babbage is the father of the computer. Now why? He was, unfortunately his parents died, but good news is he became a multimillionaire. And so now he's a professor in Princeton. He builds the, what is this called, Daniel? This is the other one. This is the difference engine. So somebody else had designed the difference engine, and they'd given it to him and asked him to build it. And so he did, and there we go. And he was not satisfied with that. He realized more could be done, more than just addition and subtraction. First of all, just appreciate the fact that without electricity, without a single circuit, without anything, he had designed a machine that you could give a number, subtract another number, and it would give you the answer back. I mean, it's incredible. Honestly, it's incredible. And somebody used the same mechanism, by the way, and built a Minecraft world out of it so that it could do all the mathematics with all the moving blocks. It was very cool. Anyway, so here he is. He has this, and he's gone ahead and designed something even better, the analytical engine. And the analytical engine design makes its way all the way to Italy, where there's a mathematician who writes an article about it. That article needs to be translated back, and so he asks Ada Lovelace, will you translate this into English and also give commentary? So she does. And she gives commentary that looks a lot like this. The very first computer program to ever be written. And what this is conjecture of what could be done with this device if it were ever actually created. It could be used in this way to be able to calculate and determine things based on inferences rather than exact data like a calculator would. Like it can do anything. And so instead of a specific type of calculation, it is more of a general purpose calculation. And so he is given the credit as the father of the computer because of this device. She's given credit as the mother, sister, the first programmer. I don't know what you call it. And, but she said this, and it's actually very fascinating. She says so she said this device has no pretensions whatsoever of originating anything, right? It can follow analysis, but no power of anticipating. Oh, but really, is she right? We know now that we can do amazing things with the devices that we have. So let's start with Alan Turing. So Alan Turing, World War I, he cracks the Enigma engine that the Germans were using to encrypt their communication, given credit for perhaps saving more lives than anybody else in the entire war. Pretty amazing, actually. A fascinating story. Benedict Cumberbatch did a movie on it called The Imitation, what is it? The Imitation Game. That's right, The Imitation Game. Fantastic, truly fantastic. But Alan Turing, not Benedict Cumberbatch, also in a Star Trek movie. I mean, it's just worth mentioning. And he also invented the Turing Test itself to be able to determine whether or not a computer passed the threshold so that it was no longer interacting with us as a computer, but as an actual companion, right? Or I'm not using the right word, but so that it would be artificially intelligent. This is a ridiculous test, and it's easy to beat, to be honest. But this is the way that it works. The machine would give its information to a person so that it didn't have to worry about vocalizing what it was doing. That person would say it to another person, not knowing where the information came from, either from the person or the machine. If they couldn't figure it out, then it passed, right? That's terrific. Nonetheless, he is the father of computer science for us because he started doing things even before these devices were capable of actually doing it. But when did these devices come along? Well, we have another 30 years before that happens. So then this movie, anybody see this movie? This is a fabulous movie for a lot of reasons, but one of the reasons was, right, so she worked at NASA as part of the early space program, and she was part of a team. And does anybody remember what her title was? She was a computer. That was it. Her job was to compute. And her job was not to analyze. Her job was not to give us some sort of insight. Her job was to figure out and crunch the numbers. She and her entire team. And one of the things that is actually revolutionary inside this movie, and you don't really think about it because there are all these other things being told inside the storytelling of this movie, is for her to even speak up was crazy because she was only a computer. That was not her role. And so it's really, really fascinating. And this is the problem. If you want to scale and you want to be able to compute the entire trajectory of a spacecraft going into space, you need more and more people because that's the way you scale computation. And that just wouldn't work. It simply cannot work. And so here we go. In 1958, this is where it all began. This is the spark that lit the fire. This is the beginning of the end. I don't know how you look at it. This is the very first part of Skynet. I don't know how you are going to look at this, but this is where it all started. The very first integrated circuit. This is where we see transistors becoming the replacement of computation and being able to enable us to scale computation in a way that didn't involve people for the first time. And so in those days, they looked at it differently than we look at it now. They didn't have the benefit of science fiction to teach them lessons about what the future is going to be like. Instead, they looked at it not as human versus machine, but human with machine versus the problem. I can actually do more because of these machines. It's interesting how that vision or perspective of the way machines work is very it's just not as popular today, right? We see it more as an adversary than anything else. And so like my dad, he worked at a Ford factory right on the line all the time. They brought in robots which would really enable him, but instead he saw them as an adversary, right? It was really interesting. Of course, we naturally see it that way until we see the evolution complete. Okay, so, and then comes Gordon Moore. Anybody know Gordon Moore? Moore's Law. So talk about a guy who should have played the lottery. The most fortuitous guess of all time. A magazine comes to him and says, how fast do you think all this stuff's going to keep getting bigger and better? He's like, I think it's going to double every 2 years. Well, who would have guessed he would be so terribly right? And for a guy who's so right, he's wrong all the time. So let's talk about that just a drop. He's an incredible guy. I mean, so here we are. This is the actual this actual line, it's perfect. Look at the straight line of it all. It's so linear. And he's able to, so it's just followed exactly what he said. So let's go over here. Back when Windows 95 was released and the Pentium was born, anybody know why we call it the Pentium? Look, in 1995, we finally got 5 million transistors on a single chip. Anybody know why we call it the Pentium? 5 million on a single chip. Well, there you go. That's a little cocktail information you can kind of tell your friends. So then, 1995, then we go to from 5 million to 160 million to 10 million, in 2010 to 1 billion per chip, 17 years ago, right? In 2015, 7 billion per chip. And then, now why do these particular times matter? Because these are all interviews with Moore where he said we've hit our limit, every single one of them, right? So he says he's right, and then of course he's also wrong, right? And so the 50th anniversary is 2017, 19 billion per chip. It's insane. It's absolutely insane. And this is what Moore always said. He said, look, there are physical limits to things. Don't expect this to keep happening. There are only so many things that can be done. And so we've taken that very large, right, transistor, and we've got it all the way down to an electron. Now, it turns out, Moore's right now, there are only so many things you can actually do, because not a lot is smaller than an electron. I mean, that's the component part of an atom. An atom isn't smaller than an electron. Okay, let's keep going, because this only gets better. So here's kind of how we've come. Look, the Cray 2 supercomputer used by the CIA to crack all the cryptography is exactly the same as an iPhone 4. It's so fast. Let's just think about where we are. The iPhone 5 comes out, it's 2.7 times faster than a Cray supercomputer. It's amazing. All right, here's an Azure data center. So Azure has a zillion data centers. Inside this building are a zillion computers, right? It's crazy, the computational power inside this building. It's a mile long, by the way. Just imagine if your job was just to mop the floors. That's exhausting to think about, you know? I mean, forget about everything else. So just imagine the chips that we can have, the computational power of a single tiny little chip, and then filling a mile-long building with it, and more than that, how many we have across the entire world as well. And so then add Google, they have their own data centers. Add Amazon, they have their own data centers as well. Think of the latent computational power of the world right now. I mean, it is something. If they all became wired together in some sort of net across the sky, they really would have the ability to do something amazing, right? And it only grows. You might think, well, there are certain parts of the world where we can't have data centers. Oh, really? What if we built a data center that could go under the water, and we could have a very short pipe then to all of the areas around the beach area, right? So it's as short as possible around not beach area, you wouldn't have a company around a beach. I mean around the shore area, you know what I mean, right? And it just grows and grows. And so not only are we beating these tiny little numbers inside a tiny chip, we're also increasing the capacity all around for us to be able to run these chips as well. It is so much power, it is like your brain should blow. But that's not what's amazing. As neat as that is, that's not it. This is what's amazing. Microsoft to double the headcount in the Sydney Quantum office. We just hired our vice president of quantum computing. If you've been seeing any of the stuff in the news, it's all about quantum computing. Is there going to be a quantum Windows? Of course there's going to be a quantum Windows. We just announced the quantum language, right? Let me jump real quick here. We just announced the quantum language. Where's my quantum language? Well, just know there's a quantum language, and it's not named yet, and I hope it's named Q#, because that's going to be terrific. And if you look at the Hello World demo, I mean, this is a quantum language we're talking about, right? It's crazy. It is Hello World with quantum teleportation. It's cool. You could say we live in a world where you could say quantum teleportation and not comma Star Trek, right? It's whatever it is. It's incredible where we are. All right, so let's keep on going. Problems today with quantum computers with regular computers that take eons. Quantum can do it when you go and get a coffee. Because remember, a quantum transistor, regular transistors in two states, right? Either on or off, 1 or 0. That's the whole nature of computers. A quantum transistor is in one of 3 states: on, off, or on-off. What? It's both on and off at the same time. Let your mind just wrap around that for a second. This is not the right session to explain that kind of craziness. Not that I ever could. All right. Then along comes John McCarthy. He is the guy who gives us the name artificial intelligence. So this is where the word starts coming up. And what is artificial intelligence? That's what I want you to take away today. Artificial intelligence is simple, right? Programs that are doing things that intelligent humans would. So when you have a spell checker and it is giving you the correct spelling of something, just like like my mom would do when she proofreads my paper that I'm writing for school. I hand it to her, she writes back, and she is the expert human that says, oh, this is wrong, this is wrong, and this is wrong. Well, I can write a computer program that can do that. And it turns out we really can, right? Word does it all the time, Grammarly does it. And so right here, that's artificial intelligence. It is artificially intelligent like a human is. That's terrific. You could have them in the room, and they would be able to contribute in their specialty where they're the expert. That's great. They can beat you in Go. They can beat you in chess. They can do all kinds of interesting things. But how do they beat you in Go and chess when you are the awesome player? Well, it turns out artificial intelligence isn't enough. It's really just a gigantic list of if statements going one way or the other. It's not intelligent. It's just faster than you. That's all that it really is. It has the entire dictionary and it can't forget it, so it does a great job. Instead now, we want to make it so that it gets better over time, and that's machine learning. So now the computer will be able to look at the results, and the next time it does the prediction, predict better. So it's not like this. It's not like if you're in Excel and you say 1, 2, 3, tell me what number comes back, right? Excel will say 4. Great. If I say 1, 2, 3, 4, 5, 6, is it going to have a better prediction? Yeah, it will. If I say 1, 2, 3, and then I say 3, 2, 1, 1, 2, 3, is it going to be able? Yes, that is not machine learning. That is just pattern finding. So the more data you give it, that's not machine learning. Machine learning is when it looks at the results of what it did before, sees how accurate it was, and changes the way it does it the next time, right? Excel is not machine learning like that. I mean, that is like unbelievable. There are actually parts of machine learning in Excel, but not that part. Okay, so an example of this would be like weather patterns. How accurate was the weather prediction? Very bad. Okay, well, let's see if we try another one. Let's try another one. Let's try another that we found the one that works. We'll use that. Still not perfect. We'll try another one. Now we found a couple more. And it's learning, and people don't necessarily have to get involved if you've enabled it to be able to learn like that. And so machine learning is the ability for its predictions, because really all of this is about predictions, mathematical predictions in the end. And so credit card fraud, when it finds credit card fraud, how many times have you been called by a credit card company that fraud has occurred only because it was you? Shopping at Walmart, right? It doesn't make any sense. So it's wrong, but it gets better, right? And it has to be wrong at the beginning so it can get better, because machine learning has to learn by itself. Stock market and all those links at the bottom of a web page that you click on, that's all machine learning. All the link bait that you guys click on for some reason, helping it to learn to be better and actually provide more and more of crazy stuff to me. All right, then along comes deep learning. And deep learning is different than machine learning. Deep learning is impossible. That's the reason, right? When you look at deep learning, often we'll talk about this in the context of neural networks. This is where a computer or a program is able to create something that wasn't there before and actually come from nowhere. And so we build the mathematical algorithms around the notions of how your brain works. That's why we call it a neural network, and the way that the neurons work inside the mind. But at the same time, there's a limitation, because as soon as we do that, we exponentially increase the requirement of computation. And even though we have done an amazing job around computation, we have done an incredibly more challenging job of creating algorithms that, even though very efficient, very capable, require unbelievable computation. But we're not done yet. By the way, I included the Star Trek Enterprise there, just because I didn't know. I mean, what says neural network to you guys? Right? I guess the brain or something like that, but it's the Enterprise. All right, great. All right. When did all this happen? Can we put a dot in the map and say, this is the moment it happened? Was it the mechanical arm that Sarah found, or was it in the winter of 2012? And it was. It was the winter of 2012. So this guy over here, whose name is too small for me to read from this far, he's the father of deep learning. Right? And so if you're wondering who it is, 1965 is when he said it first, so he gets credit for that. And so much of the work he did. Winter of 2012 is when it all happened, but let's back up to the summer of 2012. This is where it's very interesting. So the summer of 2012, Google has a group called the Google Brain, right? It's a nice group of funded data scientists trying to accomplish the impossible. They are suddenly able to look at videos on YouTube and identify cats. Now, me saying that doesn't have you guys all shocked. But there was a time 5 years ago when that was not possible. It's crazy to think where we are right now. Now it's second nature. I can have my phone do it. It's nothing to it. So able to find a cat in a YouTube video, it took 16,000 computers to accomplish. Wow, that is unbelievable. The good news, the article's like, the good news, we can find cats. The bad news is it takes 16,000 computers. So this was amazing, and it was the first of the first. This was like nobody had been able to accomplish what they had been able to accomplish, and there was hope in sight. Now, at this point in time, companies like Microsoft, Google, Facebook, they were not investing in deep learning and artificial intelligence like this, because it was so impractical. I don't care if I can help you tag your family members in your photo if it takes 16,000 computers. That's just, it's not scalable. But things changed. Then comes winter, just a handful of months later, winter of 2012. There's a competition called the ImageNet competition. A team of 3, instead of a team of 12, a team of 3 are able to win the competition. And instead of using 16,000 computers, they use less than 5 GPUs. It was the turning point in artificial intelligence when every company sat up and paid attention, where investment started coming out of nowhere and checks being written to these data scientists had more than 2 commas all of a sudden. It was unbelievable what people who could see, the futurists who could see the future, were like, we've finally made it, we've been waiting for this. This is the turning point, and here we are. And from this point forward, this is the birth of what we consider artificial intelligence. Only what we consider artificial intelligence is really deep learning and neural networks. This is interesting. This was in the news yesterday, right? So one of the ways we can do this is to take away the idea of general purpose chips, which certainly have a cost of their own. General purpose chips say, I'm able to accomplish whatever, just tell me what you want to do. But there's an overhead to that. So if you think about GPUs, they generally speaking are actually a general purpose chip. I can ask them to do many, 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 many things. But what if we had a chip that only did one thing? What if it only did Vision API and only Vision API? Then all of a sudden we can make things less costly, we can make battery life, we can make performance, everything can move towards that as well. And so we see now a new type of chip being born that can, almost like an EEPROM, where they can be flashed into a certain configuration so that they are focused only on a single task. It's very efficient. We use these inside of Azure, where if we host a VM or we're running Bing on it, you can flash it both ways. And apparently it saved us $1 billion, but what's that matter to a company that makes $26 billion a month? All right, so what is the thing that unlocked it? So we talk about it as the neural network renaissance, right? And so this is the second, right? The first is when it was born, I guess. And it's the rebirth, so it'd be another one. I wonder what the first, anybody know? Don't tell me. Do not tell me. I just like the mystery. So we have 3 things that made it really happen. First, we have big compute. We kind of understand big compute. We have big compute thanks to GPUs and thanks to the unbelievable things we're doing with transistors and so much more, right? And we can see the future with quantum computing where it's only going to be more as well. Are we going to be able to maintain this line? Of course, we'll be able to maintain this line. Of course, look at us, we're humans, right? That is such a Gene Roddenberry statement. All right, so then we have new analytics. We have new mathematics that were never possible before. This is almost like when Ada Lovelace was trying to program the computer, she would write it out by hand, and she would make up her own syntax because it just couldn't be executed because the device didn't exist. But now we have devices that can actually handle the computation. Now we have devices that can enable all the testing of these analytics. We have amazing algorithms we never had before, enabling a lot of the things that were only dreams in the past. And then finally, we have the internet. I mean, you guys know the issue with data is unbelievable. We have so much data and it's just growing every day. Well, fantastic. Finally, we have enough data we can feed into these algorithms to give us back predictions that are more and more reliable, because the more data I give it, the more reliable the prediction can be as well, right? Because as soon as whatever it is wakes up, it's going to read the internet, right? That's all it takes. Whatever it is wakes up. Well, we know that time will come. All right. There's 2 things that are just the focus of AI that you and I think about the most and that are going to enable the future that we're going to live in. The first is around CNN convolutional networks. This is where vision is unbelievable. This is where I can find a cat video, yeah, and everything else. And I can run a little application on just a recognize me and guess your gender and all these other things. Meanwhile, if I pull up Task Manager, it's not going crazy at all because we've enabled all of these things in so many ways. The other thing we can do is around recurrent networks. That's what's enabling language. So At first, I look at everything in layers. In vision, that's the way that works. I look at things in layers because that's the way your eye works as well, by the way. And then in language, I have to look at everything in sequence. And I have to remember the time frame of things and whether or not this came first and that came first. Because as it turns out, language is very difficult. And I mean very difficult. Vision is hard by itself. And you, by the way, have a fantastic brain. And here you are, so recognize the dogs, recognize the muffins. It's not easy. This is the sort of problem you give to a machine, and you're like, go for it, go for it, go for it, right? And it's like, I don't know what you're talking about. Can a machine tell the difference between this, a dog, and a muffin? Absolutely. Yes, it can. Is it hard? Sure, it's hard. But yeah, it can figure it out. Sure, it can. Now, think about language for a second. No, let's stick with vision. So this is fast. How good was good when they won the competition? So humans on average when identifying, in this case it was street signs, identifying street signs. So think about this, in the fog, in the dark, at an angle, all these possible variations of how you look at something. Your error as a human would be 1.16%. That means you get it right 99% of the time, which is what you would think. This is probably why there's wrecks on the road. But then we look at first place with just 3 guys and 5 GPUs, and they're able to do it, and they have error at less than 1. Compare it to you, they are killing you. Who would you rather have driving your car at night? A computer that can be twice as good as you, or you by itself? If you were asking yourself, like, why is everybody paying so much attention to self-driving cars? It's because they are better than you. I mean, it's crazy to say, right? Are they there yet? No, but will they? Come on, who are we kidding? Absolutely. Once you're carrying a Azure data center in your trunk, you're going to go to town. So it's going to be great. And someday we will. Someday we will. Faces are another complication because there are so many aspects to faces in order to be able to identify them. And so 2014, DeepFace, this is an example of where multi-billion-dollar companies just don't know how to name things well. But anyway, DeepFace from Facebook, they are able to now tag your faces and help you find your friends inside images with less than 3% error. Why? Because they are able to look at a 2-dimensional photo of a face, extrapolate the 3-dimensional conditions of your face, and turn, look for pictures where you're looking that way, turn. It's unbelievable. All from a RGB 2D picture. It's fascinatingly awesome, right? These are amazing things we're able to do because we've unlocked it with the data and computation we never had before. Okay, but that's not the cool part. I mean, there was that, it's just not, right? Then there's this. I'm inside PowerPoint with a picture of a cat because I always have pictures of cats in PowerPoint. I right-click and I say Alt Text, and there's a button that is right here that you can't see that says Auto Describe. I push it, and it says a cat sitting on a tree branch inside PowerPoint. Well, I'm like, that's useful. That's really nice. I like that. That explains how all the image searches on the internet work, and they're not all properly tagged, but somehow we still see them. Absolutely, I can see that. That's fantastic. This isn't the amazing side. The other side is the amazing side. This is where, instead of descriptions from images, we give it the description instead, and it draws the image. And we say things like, this is a white bird with a black head, and it has short wings, and it's sitting on a branch, and it's not looking in the internet for all these pictures that match your description. It is creating the image for you, right? Just like a technology like the holodeck, right? But it's crazy. It's not that crazy to think we're there. Now, being able to create the force fields and touch it and all that isn't there, but we have VR, right? This is me and my colleague Adam here, and we are, he's got his HoloLens on, and I've got the new VR headsets, and we're both inside the same Windows environment. Yeah, it's unbelievable. It's fantastic. We're already in the future. We're past the future. The future's behind us. It's nuts. It's nuts. Okay, let's think about how difficult language is. So here's an example. So natural language processing. This is where I'm talking to my Alexa device, and she actually understands what I'm saying. It's amazing, isn't it? And I can whisper it to her. In fact, I often have to say, hey, do you guys have a Alexa? So I don't want her to hear it because she's so sensitive to hearing it. And she gets it right a lot. She's perfect? No, of course not. Why do I call her a she? I think Alexa's a girl name, and it sounds like a girl's voice. But I know it's just a robot. It's not a robot. It's a... What is it? It's just it's a cylinder that sits on my table. It's not, okay. Okay, I saw a man on a hill with a telescope. This is the phrase. Now, what does it mean? You're a human. You can take this apart in a very simple way. Does it mean there's a man on a hill and I'm watching him with a telescope? Does it mean there's a man on a hill who I'm seeing and he has a telescope? Does it mean there's a man on a hill and the hill has a telescope on it? Well, wait a minute, I need a lot of context to be able to get that right. But that's the reason when you look at language processing, it takes it in a series so it can create context for you. So it's not like looking at a photo, is there a cat? I need your sentence and I need it in the context of a couple of sentences so I can tell you what the right thing is. The longer your paragraph, the more accurate the grammatical recommendation is from the service, right? That's because I can do all of this natural language processing in an incredible way. We have a wrapper around all of this. By the way, if you've ever met a data scientist, they're nice people, but they're smarter than me by a lot, and so I don't like them naturally. And so if you think about like the things that they can accomplish, they accomplish them in an amazingly complex way. They're like, oh, let's use this algorithm, and we're going to need this input, and we're going to need, and we're like, oh my gosh, this is serious. You guys are serious. How am I going to be able to just put this in my mobile app to make this easy? I have to become a data scientist to make the most of this. Wouldn't it be nice instead if there was a wrapper, some sort of service that was wrapped around, maybe you could call it like a cognitive service, that made it so that all this machine learning was accessible to you by just a REST call? So that's what cognitive services is. The cognitive services one is the umbrella, and language understanding intelligence service, LUIS, that's the language part of it. And if we, this is so good. You know what? It's a bummer these sessions are so short. I have so much cool stuff to show you. I'm going to show you anyway, because it's just, I mean, how can I not? You're going to love it, and then you'll be like, I can't, this is all you're going to talk about. It's the demo. I'm going to let that, no, wait. Here we go. DUET. Oh, look at that. Look at that. Well, we're going to fix it. I'm just going to get it. You guys are going to be, you'll be like, I can't believe you did this because it was the most wonderful thing. All right, so there's a button that says load. I'm going to let it load, and I'm going to show you the next slide because it's like insane. Okay. We'll go. Somebody remind me to go back because it'll blow your mind. Okay, so what? Who cares about all of these changes? Who cares about all of these things that have been done? Okay, I need to be able to apply this to my company, and my company is honestly quite boring. We have a bunch of documents. We don't have a bunch of cat videos. We just need to categorize things. We just need to find out whether or not we're doing the right thing inside our accounting. We just need to do some basic stuff. What can I do with artificial intelligence, specifically machine learning, that can benefit me? Let's think about the 5 things that can actually be accomplished thanks to all of this technology. So the first thing, these are just the 5 questions that you can get an actual answer to from one of these programs. I can say, is this A or B? Is this a cat or a dog? Better said, is this a 9-volt battery, or is this a AA battery, or is this a AAA battery? And I can do all these multis as well, right? And because everything's rolling down my assembly line, and I want to know how many 9-volt batteries have passed. I'm taking a picture of a road, and how many semis have passed, right? I don't want to have somebody there checking it off. I want you to be able to do it for me. Go. Beautiful. Absolutely, we can do this with classification algorithms. No problem. It's easy. Now, what about anomalies? This is where credit cards come into play. I want to know who in this room is the one that, ate the chili and has no respect for the rest of us smelling-wise, right? I just want to know, how do I figure out the anomaly in a group? How can I find the person who's most likely to buy the product that walked into my store? How can I find the one who has the biggest problem that I can go talk to and satisfy them ahead of time? How can I find the anomaly? Easily. I'll use anomaly detection algorithm. That's a nice name too. Perfect. This is what I can actually do with artificial intelligence. So the next is how many? I don't need it to count. This isn't Rain Man dropping a whole bunch of things and I know how many. This is how many tomorrow. I need to know how many degrees it will be on Tuesday. Oh, I'll give you a bunch of data in the back, and you tell me then, using a regression algorithm, to figure out and predict the future. And the more and more I ask you, the more and more right you're going to be. That's cool, right? That's another thing I can do. I can say things like, how many people are going to apply for this job? How many are likely going to be good? How many are likely going to, and on it goes. And the better the data I give it, the better the answer it gives me as well. And then I want to understand algorithms that are they clustering way things are organized. I want to say, inside this, how many people in this room are going to like the new movie I just made? How many people in this room would you group together as science fiction and drama? How many, and then I could go the other way. Of my movie, show me all the people that that will like my movie, right? I can go back and forth, and depending on how I ask it, it becomes more and more accurate, and I can kind of toggle in and out. And then the fifth thing that I can answer with artificial intelligence is, what should I do now? Right, so reinforcement learning. This is, remember the text game? Remember the Star Trek text game where you could go left and right and you could talk to people and shoot stuff and things like that? All those text, that's a perfect example. I walk into a room, there's a door on the left, door on the right, door on the front. What should you do next? Well, wouldn't it be cool if a computer could do it and it could go through a series of tests and be able to figure it out on their own as well? Can you make a robotic mouse that finds its way through a house? Absolutely. Yeah, it can find its way out, all the way out. It can beat a maze over and over and over again, and sure, it gets it wrong the first couple of times just like you would, but then it does it because it thinks the way you do, because it has the ability to handle reinforcement. So reinforcement isn't like giving it a cookie. Reinforcement is more of saying whether or not it's right or wrong and making it prefer to be in the right state. So as long as it's wrong, it's got to change. As long as it's wrong, it's got to change. Now I'm in the right state. Now I need to do the next action. What would be the next action that would make me still in the right state? And it figures it out from there. These are amazing algorithms. And to think they're just at your fingertips, and truly they are. Okay. What's that? Oh, you're such a good man. You're gonna love this too. You're gonna love it. Okay. This is AI duet. So this is what happens. I start playing this is a keyboard. By the way, it's not. Don't expect anything good. But I'll play along. It will hear the rhythm, the tone. It'll hear the key, and it will start playing with me, and it will be my duet player, right? And so, which set of keys is it? This one, right? So I'll go boo boo. And it starts to follow both. It doesn't understand the idea of key or pitch. It doesn't understand the idea of rhythm. It just learns what all those are based on what I'm doing. And so as I start making something that's very, very interesting and going, this is a grad student's project, by the way, and it's pretty terrific. Is it great? Like, is it truly a duet and they start making new music you've never heard before? Well, yes, it is actually making new music you've never heard before, following inferred patterns, but not the actual copying of what I'm doing. It's amazing. Is it good? No, it sucks, just be honest. But the fact that it even exists is amazing. All you need to see is the hint of the technology to know it will eventually be fleshed out and awesome. It will. You know that it will be, and it'll be some robot girl playing, and it'll be incredible, right? You just know it's going to be fantastic. All right, thanks for that. I mean, that's cool, don't you think? No doubt. I can't believe I said it wasn't good. And we're recording it. Oh man, if you're that student, man, I am so sorry. I didn't mean it. It's great. All right, didn't make my playlist though. All right, so let's think about what you can do with your data to be ready to use it. Because if you don't have the data, because this is where it becomes relevant to you. The data inside your organization is what's going to make it relevant to you. That's the way that it works. You have the data, you have the documents, you have the database, you have all the whatever you've got, all of your billing history and all of your whatever, right? You are the one who's installed all the IoT devices that are sending so much sensor information. What do you need to do with that data to make sure it's ready so that you can get the most out of this sort of world? First, you have to make sure that this is relevant data, right? You're going to have, I have three things that you need to know. How tall I am, what the temperature is outside, and the rotation of the Earth. Those are not related to each other. There is no good correlation there. If you can bring in related and correlated data, that's when it's bad. How tall I am, how much I weigh, and my age. Those are three very related things. I could get a lot of information now. Thanks, that's really great. All right. The next thing is whether or not it's disconnected. I know all three of those things, but not all of them at the same time, and I can't really relate to which person. I could just say, in this room, there are 14 females, and there are 30 happy people, and 40 people under the age of 30, right? Wow, okay, that's useless, right? It's just useless, right? So you also want to have connected data to say, oh, and which one is the happy? Is the happy the female and the one that's under 20? And all of a sudden you can start to do things you've never been able to do before. So this is you looking at your data and saying, is it connected, is it related? Then you want to see whether or not it's accurate. So not precise, right? So if we were to look at this little graph right here, it talks about what's precise. This is very, very precise, all of your data in one tiny little clump. But it's not in a clump that's anywhere near what you actually care about. The target that you care about is in the middle. So this is like super data at the top right? That is both precise and accurate, and you're ready to go, and lucky you, but most of us don't have that. Most of us instead have really broken data, but we want it to be more like this bottom one where we're like, this is not that precise, but it's very accurate. We've always been talking to the same set of people who love our products, and we're ready to go, and la-da-da-da-da. Great. So we don't have to have precision. We just have to have accuracy. Great, that's exactly what I want. That's exactly what I want. And then finally, it's around whether or not you have enough data. Because I know you think having 1 million lines of data is awesome, but 1 million lines is just the beginning. I mean, it's crazy to think where we are that 1 million rows of data is even relevant. So look at this. How much do you know about this photo? I know quite a bit about this photo. For one, I can tell you the time of year. Yeah, I think I could do that. It also looks like there might be water going on right here. What if I added just a little bit more data? Now I can say like, oh, wait a minute. I also think there's a sun, and it looks like there might even be buildings. What kind of decisions can you make based on that limited amount of data? Some. You can make some decisions. But the more data you add, all of a sudden you're like, wait a minute, there's a church in the distance. And all of these things you're able to see because you add more and more data. Your algorithm is able to see it as well and be able to make better and better predictions because of it. And so that is where some of the risks come from as well, where we start making these kinds of decisions without enough data. Let's talk about it mathematically. How many people are data scientists here, by the way? Good, just one. I know. Yeah, man, I'm nervous enough that they're recording it, so I mean, I'm right there with you. All right, so here we've got, this is just so you can see what's going on. Once you understand what it's doing, the magic is gone. That's what we want, right? We want to be able to pull back the curtain just to drop. So here on the left, we see how many dollars it is, and on the bottom here, we have on the y-axis, this is a chart, we can see how many carats. So we're talking about how much it costs to buy a certain carat diamond, right? Or what its value is, or something, right? We just have dollars 1 through 6 and carats 1 through 9. This is not, a 9 carat, anyway, it doesn't matter. So now we build a quick plot diagram just to be able to say, given that we know the actual cost of certain diamonds at certain carats, I want to lay those out. I'm like, oh my goodness, I see a pattern. Well, this is like a dream world where we see a pattern. And what is that pattern? I could draw a line that kind of shows the trend line of what that pattern is. And we would call that trend line, by the way, we would call it a model. And when you look at a machine learning model, this is it. We build the model based on existing data. So now I can say, okay, because I have this model, you can give me more data, and I can tell you where it would fit in the model, and I can tell you information. So now I could say, okay, well, based on the model that's there right now, I can predict a value around 5 that we don't have any data on, and it goes over here to 4. It's going to cost $4 for a 5-carat diamond, which is reasonable because there's no money in the future. And so now, this is a predictive model. By the way, you see there's a straight line, so that's a linear model. This is a regression model because I'm predicting a number in the future. This is a linear regression model, and congratulations, you did it. This is great. This is really great. All right, then we're like, that's not good enough. We know that it won't be exactly that. There's still kind of some wavery. So instead, I'll figure it out. And so I'll say, I want to calculate the context by drawing an envelope around the known data. And I might even exclude a point or two. See at the top, I might even exclude this point because that's kind of an outlier. I want to see where the main pieces really fall. And so now I have this envelope, and at the top and bottom of the envelope, I can do the same sort of thing and build a confidence margin so I know how close it is. Now this is important because as I have more and more data and more data, I can count more and more data as outliers. And I can get it tighter and tighter and tighter so that my confidence level is tiny. And I could say it's going to be 48 degrees on Tuesday. Could be 49. That's it. And I'm not saying somewhere between 20 and 60, right? That's totally different than somewhere in the upper 40s. That's amazing. And I could do that with more and more data and be able to pull that envelope smaller. Now this is showing 2 features, or details, right? The little pivots. Now, in a normal model, you're not going to give 2 things. You're going to give 22 things, 222 things, 2,000 things. And it's not going to be 11 dots up the line. It's going to be millions of lines, millions of dots, millions and millions and millions of dots. And the correlation between them is going to be sophisticated. And it won't always be a straight line. It'll be a curved line. And it'll be a broken line. And you're going to have to fill in the details. And lucky you, we have the algorithms to do everything I just said. We just can't do it visually in PowerPoint because it's unbelievably sophisticated. But I can hand it up to machine learning up in the cloud, and it can hand it back to me in a couple of seconds, and everything is done from there. And I train it again. And I know that next week I'm going to train it again, and I mean it's going to be better. It's going to be better every time. So now you guys are data scientists. You can all raise your hand the next time somebody asks if you're a data scientist. Okay, here are the things I want you to take away. These are the tools that you need to know that you can have to make this work for you. So first is Microsoft Virtual Academy. This is where all the free training is. Microsoft puts all the training up there. If you want to learn what machine learning is, you will lose weeks of your life at Microsoft Virtual Academy. You can play things at 2 times the speed, which is nice, so then you're losing half the time, but then you won't get as much out of it either. We have the Cortana Intelligence Gallery. This is where other people have built models for you with existing data sets that we all are learning from. So if you go to school to learn data science, you'll be using the Tulip data set, or you'll be using the police crime data set, or something like that. We've taken all of that, like the survivors of Titanic, all of those things. If you have long hair, are you likely to survive on the Titanic? Well, you can figure all that out through existing models that you can bring in for yourself. And then you can go to cognitive services. So this is not where you play. Cognitive services is what you use. You build this into your application. I don't think I have the skills to build my own model, but I can certainly train one that's already there, and then I can start using it. I want the Vision API to be able to show me where all the 9-volt batteries are. I want to use the Lewis API to tell me what people are saying so I can understand whatever it is. Great. That's what cognitive services is, and it's just a set of REST endpoints that you can do you just put it into your app and you're ready to go. And what's crazy is the first couple thousand calls are free. I have no idea the economics of today. I don't understand how we make money at all to give as much as we do. But odds are you can play to your heart's content and not even notice that you're still in the free tier. It's really great. And then finally, there's Azure ML Studio. That's studio.azureml.net. And that's where you go when you're ready. You're like, hey, I know what algorithm I want to use, and I know how to train it properly. Thanks for wrapping it with cognitive services. You got me a long way, but now I can do this custom-wise and go to town. That's where Azure ML Studios go. You can build your own experiments, share it with your friends, have workspaces, and go to, it's just really terrific. It's really terrific. All right. Usually, we're a little short on time, but I'm just going to do this anyway. Okay. There's one thing that I think is worth talking about, and I've joked about it a little bit, and it's the risks around machine learning. So the top guy, that's Bill Gates, right? The Microsoft guy, right? The richest man in the world. He's not dumb. He's not dumb. And he's seen a lot. A lot, I guess. I don't know. And the guy at the bottom, anybody know? Yeah, Elon Musk. Also, not a slow guy. He's pretty great. Both of these guys are very wary of machine learning. In fact, a quote by Elon Musk said, "We're summoning the demon." Right? He's like, you've seen the movie where like the evil wizard is summoning the demon because he can control it, but then he never can, right? He's like, we are summoning the demon with AI. And in a lot of ways, they see the real potential of, we just generally speak of it as like the singularity, but it's that moment when it turns and all of a sudden it is able to read the internet and it is able to be able to create things at a rate that's actually more impressive than what you can do, right? You have a very good all-purpose CPU up inside your head, but it's very slow, right? And theirs will be faster. It's just the way that it goes. But that's not the risk that you and I, right? Once that happens, it'll just be over. I was interviewing this one data scientist. I'm the host of Dev Radio, and I was like, "Hey, what's the risk of Skynet and everything just happening?" He's like, "Are you kidding? That's more than." I asked him. I said, "Should we all be afraid?" He's like, "No, you shouldn't be afraid. We're at least 20 years from that. That's I'm like, oh, okay. Relax for 19 years and panic. Okay, but here's the risk that we really have. Remember the Mars climate rover and that it crashed, right? It crashed because the data was wrong. Why was the data wrong? Because imperial metric conversions were wrong. That's what happened. Because if I have an algorithm that's able to predict whether or not I should stop my car at a red light, and that algorithm is slightly wrong, it's a big deal. That is a big deal. If I am making massive predictions based on the algorithms and data that I have, I need to slow down a little because it is only as good as the algorithm, and the algorithm is only as good as it actually is. We don't know how good it. What's checking the? No. I have 2 models. One checks the other, right? Oh, that's terrific. That's great. That's right. It's like the first robotic airplane. The pilot comes on. He's like, "Thanks for flying the first robotic airplane where nothing can go wrong. Where nothing can go wrong." It's great. All right. And then remember, and so Hillary Clinton, she was a presidential candidate just a little while ago. You guys should pay more attention. And she lost. But she thought she was going to win. Why did she think she was going to win? Because all the data said she was going to win. Why didn't she continue campaigning? Why did she slow down at the end? Because she had buttoned it up, right? And she lost. Because data is just data. It's not truth, right? The truth is real, and data is predicting it. How correct is the prediction? Never 100%. That's the risk of data, is that we can take so much value out of it, improve things so many times. We could find the elevators that are going to break before they break, great. But we have to realize the difference between prediction and reality, right? And the reality is true, and algorithmic prediction is just a guess. It could be very close, but it could be wrong, because we've already cut out the outliers to be able to make the prediction, and today it could be the outlier. That's the difference. All right, I think I'm done, and sorry I've kind of gone over. I just want to say it this way, right? It's human and machine against the problem. That's where we are right now. All right, thanks everybody. That's artificial intelligence.